Today I will discuss laboratory method of preparation of hydrogen gas. Now, to prepare hydrogen gas, we take zinc metal, granulated zinc. To it, we add dilute sulfuric acid or dilute hydrochloric acid. Then it will form a salt zinc sulfate plus hydrogen, or zinc plus HCl hydrochloric acid dilute is equals to zinc chloride plus hydrogen. This is the chemical reaction which takes place during the preparations of hydrogen. Here granulated zinc is taken because granulated zinc is impure. It is mixed with some different metals like copper, cadmium, silver, etc., which different metals, say zinc or mercury, zinc or cadmium, etc., two different metals when coming in contact with acid, they form a cell, local cell, which activate the reaction, which acts as a catalyst in the reaction. Hence, in absence of or instead of pure zinc, the granulated zinc is a mixture of zinc and with other salt is taken. Granulated zinc means impure zinc. Now you will see the diagram. So this is the diagram of the preparation of hydrogen gas. Here this is the round bottom flask, and this is a thistle funnel through which dilute sulfuric acid is added. Here this is granulated zinc. Granulated zinc, this is sulfuric acid, dilute sulfuric acid. When dilute sulfuric acid is added to granulated zinc, the reactions will take place like this, and it will produce hydrogen gas. Hydrogen gas will go upwards as it is lighter than air. The hydrogen gas will escape through this side tube. Hydrogen gas will escape through this side tube, and then it will be collected through water by downward displacement of water. Water will come downwards and hydrogen gas will go here. This is hydrogen gas. So in this way hydrogen gas is prepared in the laboratory. Now there are some precautions to be taken, that zinc, first the granulated zinc should be taken in place of pure zinc. Dilute sulfuric acid or dilute hydrochloric acid is to be added instead of concentrated acid. Nitric acid cannot be used, because in the earlier class I have told that nitric acid, either in dilute condition or concentrated condition, is a strong oxidizing agent, and this setting is purely airtight, so that no air can pass through it, because if hydrogen comes in contact with air, there may be an explosion. So after airtight fitting of the apparatus, then you will add dilute sulfuric acid to the granulated zinc and reaction will start. Then the hydrogen will pass here, and the downward displacement of water, hydrogen will be collected. At first the gas is allowed to escape, because that the first time some air passes out, and then you can collect the hydrogen gas. Now you have to know how to prepare or how to purify the collected hydrogen. With the preparations of hydrogen, we get some impurities like it has gases, mixed with hydrogen. These are some say phosphine or arsine, the arsenic hydride or phosphorus hydride. These are arsenic hydride ASH3. These are gaseous impurities, arsenic hydride or phosphorus hydride. These are gaseous impurities. And other is say H2S. This is also gaseous impurities, or SO2 or NO2. These are gaseous impurities, or some moisture. This is moisture. So these are the impurities mixed with hydrogen. Now these impurities have to be removed from hydrogen. For this reason, to remove arsine or phosphine, hydride of arsenic or phosphine, you have to add silver nitrate solution. That means the side tube has to be passed through a U-tube or a beaker containing silver nitrate solution. When the arsine or phosphine mixed with hydrogen will pass through silver nitrate solution, the two gases will be absorbed. Then you will get free hydrogen. Two gases will be absorbed, and there will be a reaction like in both cases HNO3 will be formed, plus you will get Ag AsAg whole 6. I am giving the detail. In the first case, if you add silver nitrate, then you will get HNO3 plus AsAg6 NO3 whole 3. That means arsine will be absorbed by silver nitrate, forming this compound. So hydrogen will be free hydrogen, or pure hydrogen will be escaped. That means arsine and phosphine will be removed from hydrogen. If you take the reaction of phosphine, you will get nitric acid plus silver phosphide Ag3P. So arsine and phosphine mixed with hydrogen reacts with silver nitrate, forming this compound. Thus these compounds are absorbed. So pure hydrogen gas will be obtained. Now to remove H2S gas, the hydrogen, the pipe through which hydrogen is passing is to be passed through lead nitrate solution. Lead nitrate solution. So if the pipe or tube is containing hydrogen that is prepared from zinc and sulfuric acid is passed through lead nitrate solution, then if any hydrogen sulfide present with hydrogen, it will form lead sulfide. A black precipitate will be formed plus HNO3. So H2S gas will be absorbed by lead nitrate solution as lead sulfide. So H2S gas will be removed from hydrogen. Now to remove sulfur dioxide and nitrogen dioxide, these are acidic oxide. You have to use an alkali, either potassium hydroxide or sodium hydroxide. That means the gas containing hydrogen mixed with these have to pass through potassium hydroxide solution. Then these gases will form K2SO3 plus H2O or KNO3 plus H2O. Thus sulfur dioxide and nitrogen dioxide will be absorbed by alkali, forming potassium sulfite or potassium nitrate. Thus it was collected through water, downward displacement of water. The hydrogen collected contains some moisture. Then it is passed through fused calcium chloride, which has a capacity to absorb moisture. Then you will get dry hydrogen gas. So, after preparation, when the hydrogen gas passes through the side tube from the round bottom flask, then the hydrogen gas purified by passing hydrogen gas at first through silver solution, which removes arsenine and phosphine. Then it is passed through lead nitrate solution. It will remove H2S gas. Then it is passed potassium nitrate solution. It will remove sulfur dioxide and nitrogen dioxide. And the last, it is passed through fused calcium chloride, which absorbs moisture, and you will get dry and pure hydrogen gas. These are the preparations of hydrogen. So you have seen the reaction, the reactant, granulated zinc, and sulfuric acid as a dilute sulfuric acid or dilute hydrochloric acid. Apparatus we have seen in the diagram: a round bottom flask, a thistle funnel, a side tube, a gas jar, and a water bath. You have to take some precautions and purifications, and last of all collection of gas by downward displacement of water.